Data is everywhere. Just look around you. Mostly we take data for granted. Labels on things, writing, signs saying where we are, even the chair you may or may not be sitting in right now could be described in terms of its data, its height, its width, its length, how heavy it is, its position relative to other objects in the room. Everything is full of data. Because data, after all, is all about the quantification of things and their relationship to other things, and the communication of that information. And so in that way, everything can in some way be reduced, even at an atomic level, to data. This leads us even to the idea of the holographic principle, which is coming out in physics, that talks about the entire universe being reducible to data. Scientists discovered that the surface of a black hole can actually contain or retain all of the information of everything that has gotten sucked into the inside of it, which means all of the three-dimensional information inside of that black hole fits on a two-dimensional surface, the event horizon. Now, they've extrapolated this principle to realize that the entire universe could work the same way, that all of reality, all of the three-dimensional, or for that matter, 4 or 5 multi-dimensional information that we see could actually just be a projection of two-dimensional information gathered at the surface of our universe. And so this actually reduces everything that we see to ones and zeros, to ons and offs, somewhere on a two-dimensional surface. In fact, people have actually used that principle to go into the field of quantum computing, where we can actually use, instead of mechanical transistors, they actually use the atoms of an object in quantum superimposed states to be on or off, or some superimposition of those two, in order to create super high functioning parallel processors, to be able to use the very state of an atom as a 1 or a 0, an on or an off, as data in the most pure digital sense. And so in this world where everything literally is data, we have an increasing awareness of the need to process and package and present that data. And so journalism has a lot to do with our ability to sift through information and present it in a meaningful way. The ability to present data. Data visualization is how we attempt to use raw, objective, emotionalist data and turn it into something that's powerful, moving, and compelling. Now, one way to do this is simply to present information with writing. But it turns out that having access to data is very different than understanding data. So from the very beginning of time, we've been searching for ways to make sense of this information in a way that is meaningful and concrete, that can not only provide access to data, but provide understanding of that data. Especially when we have to communicate this data to others, and even more so when we are not there in person to help explain it. And so this is where getting our other senses involved can be a really good way to do this. Especially since the 1800s, when we shifted from a more textual auditory culture to a visual one with the advent of the camera. And so we started beginning to mix data with visual representations of that data. And in the last couple decades or so, we've decided that we needed a new fancy shiny new name for this, the infographic. Now, here is some perfectly good data. There are 5 common variations off of the basic hot espresso-based beverage. Espresso macchiato, cafe latte, and cafe breve each add milk foam on top of espresso. Cafe latte and flat white espresso incorporate a layer of steamed milk. The steamed milk is behind the layer of milk foam in the case of the cafe latte, and without any milk foam in the flat white. Substitute the steamed milk or steamed half and half to make a cafe breve. Alternately, top the espresso with a layer of whipped cream to make an espresso con panna. And you are now trained as a barista, except for the fact that if you can make any sense of that, you are a far better barista than I. Because once again, having access to data is not the same as understanding that data. So we've tried to figure out how to turn this into something a little bit more accessible. Like this. Same data being presented, but now suddenly we can actually make sense in a very quick glimpse of how to make all of these caffeinated beverages. This is why infographics are so effective. In fact, there's an infographic to tell us why infographics are so effective. I'll scroll through this kind of quickly, but I'll put a link to it at the bottom of the page so that you can scroll through it more at your leisure. But we are essentially inundated with visual stimulus. And it's because we're good at it. It takes only 150 milliseconds for a symbol to be processed and 100 milliseconds to attach a meaning to it. That means in less than a second, far less than a second, we've already interpreted the visual data that we could have otherwise been stumbling over in order to make our coffee. But there's so much of it, 34 gigabytes of information that we process every day, and I'm sure at this point this is now a very conservative estimate, that we need to find ways to make that data more engaging and more easily accessible. Because text and pictures are just more effective when used together, more persuasive and more intelligible, and easier to recall. This is the dual coding theory, right? We have to mix the way that we hear information and see information and experience information in order to retain it. And that can allow us to stick with this information and end up enjoying it for a lot longer than we might have had the attention span for otherwise. After all, we've been reading this for 1 minute and 28 seconds so far. It's no wonder infographics have been so successful. Now, part of what makes graphical representations of data so appealing is that in many cases it has been thought to transcend language entirely and to be universally accessible. This has been so widely believed that we even put it to the test by shooting it off into space. That's right, in 1972, the Pioneer was given these plaques, and scientists realized that this thing is going to far outlive its usefulness in human standards, so once it leaves our solar system and is no longer communicating with us, there is entirely a plausible possibility that it could come in contact with something we don't know about. And so they wanted to communicate a little something about us. So they attached these plaques, which are essentially pictographic representations, symbolic representations trying to describe humanity. And so you have images of the male and female anatomy relative in scale to the size of the ship itself, of the Pioneer itself, which is that weird sort of curvilinear, triangular, and rectangular shape there behind the people. They've also shown Earth's position in the galaxy relative to prominent pulsars and their frequencies, which is that sort of waveform sunburst in the middle there, and Earth's position in the solar system with this sort of silly-looking representation of the sun and the planets and the Pioneer launching off of that third planet from the sun. Whether or not this is actually going to be interpretable to some alien life form is up for grabs. But this is how much we believe in the power of images to convey complex data. And it goes back far further than 1972. In the 1960s, the word infographic does actually show up, even though we don't use it in the way we currently use it until the 90s. In the 60s, it was used as an adjective, meaning anything that combined information and graphics. And so this was an infographic sign about what a good listener would be. But infographics have been around long before we had that name for them. And before that, they took the shape of other types of data visualization, like graphs and other diagrams. In the 1920s, Otto Neurath defined this new type of data visualization called the isotype. And this is where you have a symbol of an object that represents a certain number of that object. And so here you have each person representing a certain number of people, and each book representing a certain number of books, or maybe those are textiles. It's hard to see in this image. But this allows you to get a sense of proportion of how many people there are compared to the production and output. And we can go back further, even into the 1850s, when the Crimean War was going on. And remember, Crimean War is the cannonball Photoshop escapade that we talked about last week. The Crimean War, to give you a little backstory, the Roman Catholics and the Eastern Orthodox Church are basically fighting over the right to the Holy Land in Turkey. And this led to a war between Russia and France and the Ottomans. Everyone's fighting each other. The churches actually worked out their differences, but that news didn't make it to the rest of the nations, and so this war kept going. And this led to a re-examination of a lot of communications practices, because the breakdown in communication led to a lot of unnecessary bloodshed. One of the pioneers in this reevaluation was actually Florence Nightingale. We know her as the nurse, but she was actually a pretty accomplished data specialist. She decided that she needed to find a way to adequately communicate the improvements that hospital conditions needed during the Crimean War. And so she invented this coxcomb graph that sort of combines a pie chart with a bar graph and allows you to show over the course of this war all of the different unnecessary deaths and what their causes were. And it turned out that a huge amount of deaths were attributed to just poor sanitation and bad conditions. And this was really integral in trying to start the movement to revolutionize the way hospital and sanitations worked. But we can go even further back than that. 1700s, 1786, William Playfair puts out this book of statistical graphics. He is the innovator of statistical graphics with his text Commercial and Political Atlas, Economics of London. And if you look closely, you can see on the right here this thing that looks very familiar now. But this was an entirely new invention for this piece of work. And this is the very first pie chart, where you can break up something by percentages and show parts in relation to a whole. And this was in 1801 that the first pie chart was used. But rewind even further than that, and we can go all the way back to the 1600s. The 16th and 17th century, people like Copernicus and Kepler are using graphical representations to convey the data surrounding the sun's orbital patterns. You could even go further back, maybe the 11th century, to cosmological diagrams like these Tibetan mandalas, in which you're conveying the entire cosmos and the relationship, both spiritually and metaphysically and physically, of these spheres or celestial bodies. If you're unfamiliar with mandalas, they are meditative images in which the person practicing the meditation would imagine that they are walking through this temple structure, seen as an aerial shot of a temple structure. And so it's actually a map of a temple, seen as a conflation of that temple and a cosmological diagram, where you move from the outside in towards truth, which resides at the center. So you've got a vast amount of data being compiled here into these practical and useful spiritual and metaphysical images here. But 11th century, that's not even close to as far back as we could go. Go all the way back to the 3rd century, and we can see symbolic pictograms from the early Christian symbols, where they would carve little pictures like the ichthus fish to try and show where their meetings were going to be. Or go back further than that, to 3,000 years before those Christians were doing that, to the Egyptian hieroglyphics, where they're taking linguistic data and transforming it into a visual array. Or perhaps even further to 7500 BC, where the very first map was discovered in Catalhoyuk, part of this cave. And if you look closely at the bottom here, this is a reconstruction, reproduction of what they think the original image would have looked like. You can see in the top image, this is what survives today. And this is actually an aerial diagram of all of the communities, the houses and the living quarters of all of the people who lived in this cave system. And caves are no stranger to pictorial representations of data. Go all the way back 30,000 years before Christ, and you have the Chauvet cave paintings, where there's, of course, a lot of debate over exactly what they were trying to accomplish with this, but early Homo sapiens were trying to convey something in terms of either ritual or migratory patterns or strategy for hunting, involving these animals. Again, the conveyance of data in pictorial representations. Now, that's 35,000 years ago, but National Geographic recently came out with an article that actually found that more than a dozen cave paintings were found all across Spain that date back to 65,000 years ago. But that's not actually where Homo sapiens lived, in Spain. Instead, they think that these cave paintings would have been done by Neanderthals, proving that maybe they were not actually the lowbrow knuckle-draggers we think that they are, but rather they might have been cognitively on par with Homo sapiens. And what's more, in southern Spain, these Neanderthals were apparently building seashell beads and using pigments that dated back to at least 115,000 years ago. Now, what that tells us is that Neanderthals and Homo sapiens came from a common ancestor, which means that if all of this holds up, it is entirely possible that the cognitive ability for symbolic thought and artistic representation could date back 500,000 years to that common ancestor. In other words, we are hardwired for this stuff. Making pictures to help explain things is kind of what we do. Which brings us to current infographics. A far cry from those cave paintings, but accomplishing essentially the same goal. And in the next segment, we're going to ask the question, what's the most important part of an infographic? Is it the data, or is it the design? Is it the info, or is it the graphic?